So this is Suresh, and today we will learn about the fast RCN and different kind of networks like RCN, fast RCN, other kind of object detections networks available. And there are a lot of problems with RCN. So the specific like accuracy plus time. So that all things resolved by the RCN. So I will explain how RCN fast RCN different from the RCN. Yeah, so basically, first I will explain specific pipeline. So here there are two things in fast RCN. The first called that backbone network, and that called fast RCN network. So this is called the fast RCN network, and the other part that called uh, RPN, that called region proposal network. That's called this is the region proposal network. So in RCNN also there are region from the CNN, and they will pass again all the region. So that's why it's taking the more time. But here the concept is different. Uh, Taking from the whatever reasons, n number of proposals, and further for the like proceed to the next fully connected layer and evolution layer, and then classify and classifiers and the regression for predict the bounding boxes here. So yeah, so there are two things. So there are two things and independently working on that. First like RPN, and second is fast RC networks. So the main architecture covers like first thing feature generation stage. So feature generation stage, generally people use VGG16 and other like VNG networks. And so there are a lot of networks right now like for feature generations, different kind of CNN architecture use. So I will explain here like VGG16 as a for feature generations. The second thing in architecture that called region proposal algorithm for Zernet predict for bounding box and end class. That's the second. And the third is like classifying the layers. So classifying like this object is particular object. Yeah, this is a background. Yeah, whatever. So and fourth is that called especially regression layer. That regression layer especially for predict the bounding box and coordinates. So the particularly for particular object bounding boxes. So there are four values is there like the top left coordinates in height and width of that particular objects. So there are four things for usually consist this network. And overall networks I will explain how work fast RCNN with RPN and fast RCNN. So fast RCNN detector and RPN, so combined with both network that call fast RCNN. So here in this particular diagram you look out the backbone network as a CNN. So uh, in there are you look that key the backbone CNN here and CNN here. So these are not different network. These are one networks only the for explain and for visibility purpose. The diagram show is a different. So both are same. So this box are also same. So after passing the image as an input for backbone network as a CNN, we are getting that 16 to 40 and the depth of the convolution like 512 and that size and output of. So we are getting the feature map of after the CNN that called the feature map, and both feature map used for proceed. So that feature map passed to the. So this network called RPN that called uh, region proposal network. So this is and for propose the reason here the concept use that anchor boxes. So anchor boxes here is a selection of the anchor boxes taking as a size of anchor boxes plus aspect ratio. So size of anchor boxes like 128 to like 512 and 1028. So there are three and three aspect ratio like 1:1, 2:1. So there are overall sizes like 3 into 3 that call 9. So and so that anchor boxes. So anchor boxes used for select the object. For example, this is the anchor boxes, right? And this is anchor boxes. So after propose the region. for example, this is the person, and for select this person we use this 9 size of anchor boxes, and here for select the horse, that anchor boxes. So using that anchor boxes, here the region proposal network give output as a n number of region proposals. Region proposal means this regions can be like you can this can be as a objects. So that region proposal used for the further processing. So that region proposal use, so this using this region, so this will pass to the this network. So this region cropped from this feature map, the backbone network feature map, and that cropped feature map, after cropping that feature, every crop we will do ROI pooling. So ROI pooling use the max pooling here. So here also fixed size of region proposal, and here output is a 16 to 14 and 512 the depth of. So the crop the feature map, crop the region. So ROI means region, or like here ROI called like is we apply pooling here only the proposed region. So whatever proposed the region here, we are applying pooling here. So for and output of this ROI, output of cropping of this region output, then that will be output like 14 into 14, or depth is uh, 520. After ROI pooling, so ROI pooling, like we will do max pooling with filter will 2 into 2 into feature, then we will get half of whatever input size. So like 14 into 14 into 12 520, then we will get output like say half of 14 like 7 into 7, and 520 is the depth. So and n is the number of region proposal. So that's output of this, and that output passed to the fully connected. Let's proceed, and both the and output of this fully connected layer units passed to the there are two networks there. First network, the above network for classifying the object, and second is like bounding box regression. So bounding box regression, it will predict the objects, so predict the coordinates of particular objects. And here the second network is you use for classify the object. So I will show in the next picture how this is work. So I will show how RPN is work. So yeah, so now I will explain like anchor boxes concept, how anchor box select the particular object. So here this diagram showing this RPN, region proposal network. So how that region proposal network will work, I will show here. So region proposal network, like this is output of that feature map. So here this is the feature map for backbone CNN, and output we are taking here. Now this region proposal network here, and we will use the anchor box concept here. So anchor boxes, like we are taking n anchor boxes, and number n is like we are taking 9 anchor boxes here. So and different size of anchor boxes, 1 2 3 dot means like 9 type of anchor boxes. And then the output of this region proposal network, output is n score and 4 and coordinates. So n is the 9, right? And here n is equal to 9. So 9 into 2, that called 18, and 9 into 4, that called 36 coordinates. So and how the calculation map with for classification purpose and for predict the bounding box, that's next diagram will show. So similar this output, these both output taking here, like this n unit is called 36 and n unit is called 18, right? So output is called like k is the anchor boxes, like n is the anchor boxes. So so here like you will see 4n means n is 9, 4 is, so 9 into 4, that called 36. So here we are getting the 36, and here 18. So this will pass to the for regression model. Regressions, it will it will predict the bounding box coordinates, and here it will pass to the classification network. So classification, so there are two classes here, one class for object and another class for background. So it might be that region, might be a object and might be a blank background, right? So there are two classes. So we binary classifiers. So every region classify as a, it should be it might be a object, yeah, it might be a blank, yeah, it might be, we can say. So like negative class, we I'm calling the negative class as a background. So background is the negative class. If we found object, then that called positive class. So there are two class for particular. That's why we are getting is 18. So here n is number of anchor and score is 2. So here score is 2 score, like it should be 1, yeah, 0. 1 means is, yeah, this is object, and this is the class of object, and score 0, 0 means is not, we are not found any object, this is the. So due to the score is equal to 2 means n into 2 is 18, so we are getting here 18 here, right? So that's why we are classifying all things like, yeah. So this is the output size of this, like 4 into 60, that height and width. 9 is the anchor boxes, and 2 is that class. So that final output. So this is all about um, fast RCNN and how fast RCNN works.